Hello, it is the class of Indian Institute of Competitive Studies, which is powered by Food Tech Club. I am going to start the class of GATE Mechanical Engineering, and my name is Lutfullah Kadiri, and I have my highest qualification, that is Masters in Engineering Mechanics, and specialization is Solid Mechanics. I did my degree from Indian Institute of Engineering Science and Technology, Shivpur, which is situated at Howrah. Well, that's all about myself. Now let me start from the beginning of this course of GATE Mechanical Engineering. This is the syllabus of my part. I will be covering these three subjects, that is engineering mechanics, mechanics of material, and theory of machines. Well, in engineering mechanics part, first we will start from the free body diagram and equilibrium. Well, before knowing that, we need to know what is our mechanics. What is mechanics? Well, we need to know the origin of the word mechanics. The word mechanics is originated from a Latin word, and that Latin word is mechanicus. That Latin word is mechanicus. So, what is the meaning of mechanicus? Mechanicus means a mechanic. So, you all know the job of a mechanic. Mechanic does some job on machine parts, okay, and he actually repairs also the machine parts. Well, that is the origin of the word mechanics. Now I will tell you the definition of mechanics. Definition of mechanics. Mechanics is a branch of physics which deals with force and its application on a body. So, if we apply some amount of force and if we analyze the force on a body, then that branch of science is called mechanics. Now, I mention one thing, that is force. Okay, while defining the mechanics, I have mentioned one thing, that is force. So, what is force actually? What is the definition of force? Well, we all have already idea about the force as we studied in the school level, but still I am telling you the definition of force. So, force is an external agent which changes or tries to change the state of rest or the state of motion of a body. So, what is that actually? Suppose this is a body, let me take a wooden block is here, okay, that is kept on a table. This is the table surface and we are applying some external agent, okay. So, it will move in this direction. So, the body or the block, wooden block will come to this position after application of force, okay. So, this is, we are trying to move our body, okay. So, that means we are trying to change the state of rest condition into motion condition, okay. And suppose somebody has pushed it in this direction, okay, and the body has started moving in this direction and you are stopping using this external agent, okay. So, that is also a force. Now, the most vital thing I am going to tell, that is whenever the force is applied and the body is not moving or you cannot stop the body, but you have applied some external agent, that is also a force, okay. Whenever some effort is applied, okay, to stop a body, but you are unable to stop the body, or if you are unable to start moving a body just because of the heaviness of the body, okay, but you have tried it, that try is also a force, okay. So if it is a bigger body, you will not be able to move it, but you have tried to move it, that try is also a force, okay. So what kind of quantity is force, whether it is a scalar quantity or it is a vector quantity, that we have to know also. So that we will know later on. Now I will tell you the classification of or the branches of mechanics, okay. So the branches of mechanics. Branches of mechanics. The mechanics branches are mainly of two branches are there, main two branches are there. One is solid mechanics, So what is solid mechanics? Solid mechanics is the force analysis on a body when the body is a solid body, okay. Solid means, we all know solid means a body which has some proper shape and size, okay, that is solid. And fluid mechanics. So what is fluid mechanics? That is the force analysis on a body, and the body is a fluid body, okay. Fluid body means a fluid body doesn't have any proper shape, it always take the shape of the body where it is kept, okay. So we will not go to fluid mechanics part, we will be studying the solid mechanics part only, okay. So in solid mechanics also we have two part. One is statics, another one is dynamics. So these are the two parts of solid mechanics, one is statics and the next one is dynamics or dynamics, whatever you can call it. So what is statics? Statics is that branch of solid mechanics, in which the body always in rest condition. Rest condition means the body is in stationary condition, the body is not moving, okay. That is the part of solid mechanics where force analysis is done on a body which is at rest, okay. And what is dynamics? Dynamics is that part of solid mechanics where the body is in moving condition, okay. We also have two more parts of each branch, that is solid mechanics has also two parts, that is statics and dynamics, and statics has also two parts. Statics has also two parts. One is rigid body mechanics. Rigid body mechanics. Rigid body mechanics. And the next one is deformable body mechanics. Deformable body mechanics. So rigid body mechanics and deformable body mechanics, these are the two parts of statics. In the same way we have dynamics, and dynamics has also two parts. One is kinematics, another one is kinetics. And another one is kinetics. So what is kinematics and what is kinetics? and what is rigid body mechanics and what is deformable body mechanics, that I will define now. Now at the starting I will tell the rigid body mechanics. So what is that actually? A rigid body mechanics is that part of statics where the body is a rigid body. Rigid means what? Rigid means a body which never changes its shape and size after application of force. If we apply some amount of force on a body, the body will not change its shape and size. That is rigid body mechanics. Okay. That means, let me draw a body. Okay. If you pull it from both the sides, the body will change its shape, it will be lengthened. That means the length of the body will be increased. It is quite natural that the length will be increased if we apply some amount of force. But in case of rigid body, it will not be increased, it will be as it is. Okay. That means there will be no deformation, but it is not possible at all. Okay. Why not possible? Because if you apply some force, the body will deform. It is a natural way. Okay. But we are considering it as rigid body for just the sake of calculation. For calculation purpose, we are considering it as the rigid body. Okay. Now the deformable body mechanics. Deformable body mechanics is also called strength of mechanics of materials. It is also called mechanics of materials or strength of material. Okay. Now what is that actually? Deformable body means the body will deform, the shape will be changed after the application of force, and how much change is there and why it is getting changed, how much force is applied for a particular change. So that will be calculated in this part of mechanics. Okay. Well, that's all about this statics, and now I will go to dynamics part. So what is dynamics? Dynamics is the body is in motion. Okay. And we are doing the force calculation. So in case of dynamics, there are two parts I told, that is kinematics and kinetics. What is kinematics? Kinematics is that branch of dynamics where the force which is causing the motion is not considered, all the other forces are considered. Okay. That means we are considering the velocity, acceleration and the displacement, not the force which is causing the motion. Okay. Now in case of kinetics, in kinetics we are considering the force which is causing the motion. Okay. That is the kinetics. Now I will go to the definition and description of force. As I have already described the force, now I will tell you the representation of force. Representation of force. So how to represent a force, that we have to know. Okay. As I told that force is a vector quantity. Okay. Because force has both direction as well as the magnitude. Okay. So we have to represent the force by mentioning the 3 points. Number 1, that is the point of application of force. Point of application of force. That means in which point you are applying the force. That is the point here, okay, to be discussed. So this is a body, you are applying a force, and the point on which you are applying is this point. And if you apply the force in this way, the point at which you are applying is this one. Okay, A point, B point, and if you are applying the force in this way, So point of application is this one, that is point C. Okay, so these are the point of application. Okay, now number 2, the magnitude. Magnitude of force. So what is the magnitude? That means amount of force. How much amount of force you are applying, that is the magnitude. Okay, so how will you tell that magnitude? Magnitude you have to tell in terms of Newton or in terms of dyne. Okay, or kilonewton, meganewton, or giganewton, whatever it is, but the basic unit is Newton or dyne. Okay, so what is Newton, that I will tell you later on. Now come to the third point for representing a force, that is the most vital point, that is the direction or direction of a force. Direction of a force. So in which direction you are using the force, that is the most important thing. Okay, that will change the motion. Okay, now you see in the figure, this is a body and you have applied a force in this direction. If you apply the same force and same at the same point in this direction, the direction is getting changed. Okay, and if you apply the force at the same point in this way, so that is also the changed direction. Okay, so according to the direction, the body will be feeling different kind of, I mean, motion on the body. Okay, motion may not happen even. Okay, so reaction will be accordingly. Okay, now this is a vertical direction, so you have to mention that the force is applied in vertical direction. That means the angle of the force, it is the direction. Okay, so what is the direction angle here for this force? Suppose this force is F1. Okay, for F1 force the direction is 90 degree. Okay, so these are all about point of application of force and magnitude of force and direction of force. Now I will go to the point, how will you measure the force, that means the magnitude of force. Okay, direction is measured by the angle of the force. Okay, with respect to horizontal axis or vertical axis or whatever the axis considered by us. Now I told you that I will describe the magnitude of force. So magnitude means the amount of force. So how will you measure, how will you say that how much amount of force is applied? Okay, you have to specify some unit of that. Okay, so the unit of force is Newton. Unit of force is Newton. So what quantity of force will be called as 1 Newton? That we have to know. If we apply a force which is generating the acceleration of 1 meter per second square in case of a body which has mass of 1 kg. Okay, so we are applying some amount of force which is, suppose this is a body of 1 kg mass, 1 kg mass. Okay, and in this 1 kg mass we are applying some amount of force. Okay, and this body will be moving with an acceleration of 1 meter per second square. If it happens, then the amount of force which is applied to create this much of acceleration in a case of 1 kg mass is called 1 Newton. This amount of force is called 1 Newton. Okay, now in the same way you can define the one dyne also. Okay, dyne is a, this is a SI unit. Okay, SI unit, and dyne is a CGS unit. Okay, so CGS unit is dyne. Okay, so how much amount of force is called 1 dyne? All the things are same, only in place of kg it will be gram, and in place of meter per second square it will be centimeter per second square. So what will be the definition of 1 dyne? That means 1 gram of mass is there, and you have to generate 1 centimeter per second square of acceleration by applying a force, and that force is called 1 dyne, and that amount of force is called 1 dyne. Okay, now this part is complete. Thank you so much for listening my lecture. Thanks a lot once again.